All right, welcome back for part 2 of our lesson on circles. Today, well, we're continuing with what we were doing earlier, which was talking about chords and circles. Again, forgive my drawing of a circle, it's not great, but we're going to continue working with chords. But before we talk about chords, I want to talk about some terminology that we will be using. So for any 2 points on a circle, it forms 2 arcs. If the arc is less than 180 degrees, then it's a minor arc. If it's greater than 180 degrees, it's a major arc. If it equals 180 degrees, then it is a semicircle. For each arc, there are an infinite number of angles that you can make off of that. You can make that angle. You can do the central angle. You can do an angle with its vertex on the circle. You can even do an angle outside of the circle. So, for all 4 of these angles, angle E, angle D, angle X, and angle C, for all 4 of those angles, they intercept the same arc. So arc AB is what is called the intercepted arc. Whatever arc an angle forms and is interior to the angle, that is the intercepted arc. Now, all of these angles, with respect to that arc, these are called subtended angles. So angle D subtends arc AB. Angle X subtends arc AB. Angle C subtends arc AB. And angle E subtends arc AB. So if an angle intercepts an arc, that angle subtends the arc. So for every arc, any angle that you can build off of it is called a subtended angle. So that's the terminology we will be using for this video. And specifically, the types of arcs these types of subtended arcs that we will be working with are going to be ones formed by 2 chords that intersect. And specifically, the 2 chords will intersect on the circle. Like this. If 2 chords intersect on the circle, the angle that they form is called an inscribed angle. So in our case here, angle ABC is an inscribed angle, which means that its vertex is on the circle and that the 2 sides are 2 chords of that same circle. So angle ABC is an inscribed angle. Now there is something special about inscribed angles. In fact, there is a theorem about inscribed angles, and it is appropriately called the inscribed angle theorem. What the inscribed angle theorem says it says that the measure of an inscribed angle sorry, my mouth works faster than my hands. So the measure of an inscribed angle is half the measure of its intercepted arc. So the measure of, I wrote measured up here too. That was my bad. The measure of an inscribed angle is half the measure of its intercepted arc. Well, that's a theorem. So we can't just assume that it's true. Oops, didn't mean to hit the camera stand. We can't just assume that it's true. We need to prove it. But we're done formal proofs. We're not going to do a formal proof of this. So we're just going to talk our way through why this is true. There's really three cases for an inscribed angle. There's three cases for an inscribed angle. One is where one of the chords is a diameter. So that's one inscribed angle case. Another is where the inscribed angle contains the center. And the third case is when the inscribed angle does not contain the center. So there are three cases we need to concern ourselves with. When one of the chords is a diameter, when the center is interior to the inscribed angle, and when the center is exterior to the inscribed angle. So let's start with that first case, when it's a diameter. Oh, that's not very good. I guess that's not erasing well either. Oh well. So one of the chords is an inscribed angle. One of the chords is a diameter. Now, if we draw the radius to the endpoint of the other chord, we just made our central angle whose measure is the same as the intercepted arc. Another thing that we just made is we just made a bunch of congruent segments. Because all of those are radii, all those segments would be congruent. And because all those segments would be congruent, this triangle here is an isosceles triangle. So if this is measure of angle 1, that's measure of angle 1. Wait a minute, angle 2 is exterior to that triangle. The measure of an exterior angle is equal to the sum of the measures of the remote interior angles. So measure of angle 2 equals 2 times the measure of angle 1. So the measure of angle 1 is half the measure of angle 2. The measure of the inscribed angle is half the measure of the intercepted arc. Ta-da! We just proved it for the first case, when one of the chords is a diameter. The next case is when the center is interior to our inscribed angle. So that's angle 1. And this would be angle 2. So the measure of this arc is the measure of angle 2. Now this time, if we draw in the diameter, that diameter splits up angle 1 into 2 parts, splits up angle 2 into 2 parts. So that means this arc is C and this arc is D because of these central angles that correspond with them. Well, based on what we just found out, A would be half of C. B would be half of D. So the measure of angle 1 equals A plus B. In other words, C over 2 plus D over 2. Or C plus D over 2. Well, measure of angle 2 equals C plus D. So the measure of angle 1 equals the measure of angle 2 divided by 2, which is half the measure of angle 2. Well, that's pretty straightforward. Now there's just one more case that we need to talk about, and that is when the center of the circle is exterior to the inscribed angle. So something like this. It's measure of angle 1. It's 2, so that's measure of angle 2. So this time, if we draw that diameter, this is 180 minus, oh, no, it's not 180 minus, I'm sorry. Just going a little crazy. But if I call this A and this B, this central angle corresponds with that, so that's B. And A is the inscribed angle for B. So A is just B over 2. Well, this whole thing would be B plus measure of angle 2. Well, this piece here, or this whole thing here, will be 1/2 B plus measure of angle 2. So A plus 1. So that means A plus 1 equals B over 2 plus measure of angle 2 over 2. Well, we already just found out that A is the same as B plus 2, so those would subtract off to 0. So the measure of angle 1 is half the measure of angle 2. So it works for every single one of our cases. It works every single time. And that's our inscribed angle theorem. So with the information about chords and with the inscribed angle theorem, you should be able to complete the assignment. And otherwise, you're all set to go. Have a good day and send me a School G message if you have any questions.